each question that is told, we can answer them. And Lord, I want to thank you, Lord, for everything you have done for us, Lord, and for bringing everyone to this meet, Lord. I want you to bless our hearts and bless our souls. In Jesus' name I pray. Amen.
Amen. Thank you very much, Ms. Hilton. Thank you. Which school are you from? Which school are you from, Ms. Hilton? Oh, she has muted already. All right, so students, other colleagues who may be on the platform, welcome to the first day in the Ministry of Education's CSEC Chemistry student camps. These camps are designed to help you in your preparation for your examinations. As you would have noted in correspondence from the ministry, it is 3 days of camps, right? And each day we're focusing on different topics, so you don't want to miss any session. And all of these camp sessions will be facilitated by master teachers in chemistry, right? So you will be hearing from the very best that we have, all right? And our first day's session will be conducted by Mrs. Elaine Williams, master teacher in chemistry from Montego Bay High School. Is it for girls or just high school generally? For girls. Your mic is muted.
For girls.
All right. So without any further ado, I will turn over to Mrs. Elaine Williams, who will take you through. Make sure, students, you have your books to note information. Any questions you have, please use the raise hand feature. No unnecessary talking in the chat unless you're answering a question or posing a question or responding to Mrs. Williams, okay? So let us have a good session today. Blessings, over to you, Mrs. Williams.
All right, thank you so much. Good afternoon, everyone. As you heard, students and some teachers are also here. Good afternoon, and we hope to have a wonderful 2-hour session. I have found that in teaching chemistry, time flies. So by the time you realize it, the time is up. So Ms. Hilton, who prayed, is from Green Pond High in St. James. And I'm from Montego Bay High, just down the road. We thank you for that, and greet your teachers, also headed by Mrs. Ebanks. All right, so how do you feel? Are you ready for exam? Type how you feel in the chat about chemistry exam, CSEC chemistry. Type in the chat how you feel and tell us if you're ready, and let's see what's happening. All right, so already nerve, bad, not ready, 8 out of 10, ready, LOL, overwhelmed, halfway ready, not ready, nervous, extremely nervous, no, someone's in the middle. All right, I hope you know qualitative is almost near the end, so let's see what we can do today. It's killing me. Okay, don't let it kill you. We're gonna see how ready we are today, especially under qualitative analysis. Okay, great. Somebody's oversaturated, and you'll notice that everyone is having some sort of revision. So there is the opportunity for you to join different platforms, and also a lot of things are on YouTube done by your teachers in Jamaica. You can also look for those, which will help you. And somebody says they're ready, like Freddie. All right, so we're going to have a PowerPoint, of course, which will help. You can take pictures, you heard, take notes. If you have any questions, type those in the chat, and let us see how quickly we can go through. And we'll be looking at, of course, some past paper questions. All right, can they see what's happening?
Yes, we're seeing.
Okay. All right, so we're doing revision and review. And as you heard, my name is Mrs. Elaine Williams. Online, you can call me Mrs. E. Willie. And we're going to be looking at qualitative analysis. So if you look at that picture already, you can see that something is happening. And qualitative analysis, of course, quali as opposed to quantitative means that you just want to find out what a substance is made up of, usually cations and anions. And there are some specific tests that we can use to determine that. But did you know that qualitative analysis is actually a combination of quite a few things, including acid, bases, and salts, solubility of salts, and different types of chemical reactions. For example, decomposition, redox, and ionic precipitation. Were you aware of that? All right, so we're going to look at very briefly at the action of acids, and we all know that acids react, and when they react, they form salts. Acids react to form salts. However, they react slightly differently with metals, bases, and of course, carbonates and or hydrogen carbonates to form some other things, all right? And I think here it tells you acids will react with metals to form the salt and hydrogen gas. Acids will also react with bases to form salt and water, and they react with carbonates and or hydrogen carbonates to form salt, water, and carbon dioxide gas. So who can type in the chat to let us know, how do you know a gas is coming off of a reaction? How do you know a gas is being formed? And you will have to tell me, I am looking for my chat.
Yes, we're getting some answers. Bubbles, effervescence, fizzing. Yeah, those are the responses.
Okay, good. Yes. And somebody saying for hydrogen, a lit splint stays lit. Is that true, everyone? Will a lit splint stay lit? Okay, I'm hearing no. It's somebody says relight. Will it relight a lit splint? Okay, it pops. So somebody said, all right, the person said it was oxygen, sorry. So oxygen will relight a glowing splint, which we're going to get to in a few minutes. Good, so here's a popping sound, good. All right, also solubility of salts. So we talked about salts, and salts are made up, you know, of cations and an anion component, which might be straight element, or it might be a radical. For example, a sulfate or a phosphate, carbonate, etc. And so you should know this list already, because of course we're just reviewing, but all nitrates are soluble, all hydrogen carbonates are soluble, usually because of the hydrogen, which gives it the form of an acid salt. And so all acids, you know, are aqueous or soluble. All potassium, sodium, and ammonium salts are soluble. And at my school, we call them the Past Students Association. PSA, potassium, sodium, and ammonium, they're all soluble. All halides are soluble except lead and silver, which we will meet when we get to the past paper question. All sulfates are soluble except barium and lead. And so you have to learn the exceptions so that when you do your qualitative analysis, you are able to quickly identify the substances that are making up the compound. All carbonates, phosphates, oxides, and hydroxides are generally insoluble except PSA. Now, some substances might be sparingly soluble, but we will not go into that in detail today. All right, so gases, as you said, formed from acids, bases, and salts include carbon dioxide gas, hydrogen gas, And ammonia gas is formed by the reaction of an ammonium salt and an alkali. Ammonia gas is the only alkaline gas. Hydrogen is neutral and carbon dioxide, as you know, is an acidic gas. Now, gases can also be formed by decomposition and or redox. So which gases here can be formed by decomposition? So we go back to the chat to see which ones are formed by decomposition. And a question about the presentation, it is going live and it's going to be on YouTube so that you can watch it over and over. You can stop it, you can take a picture, you can clip, you can snip. All right, so that will be available. All right, so carbon dioxide by decomposition. And a question here, nitrogen dioxide, yes. Now you have different types of decomposition. Remember now, someone else will be doing electrolysis, which is electrical. And of course you have thermal, when you heat the substance. And there is another one. Can anybody tell me what other type of decomposition is? And they will tell you the YouTube channel name so you can get to see it after. Yes. What other type of decomposition? Electrical, as in electrolysis, thermal, as in heating the dry compound, and somebody says photo, as in photolytic decomposition. Okay, is there any other? And somebody's gone into bio now, denitrificating, decomposition, denitrifying. Okay, all right, and it's good when we can integrate our different subjects. And yes, nitrogen dioxide is there somewhere in our nitrogen cycle. So there's one more type of decomposition and it starts with C. Ah, good. So Normanique Powell says catalyst. Good, catalytic decomposition. Which one there is formed by catalytic decomposition? And notice how we go across subjects and topics. All right, somebody saying oxygen, good. And oxygen is formed by the catalytic decomposition of which compound? All right, quite a few saying oxygen. Anybody remember the compound? I'm seeing ammonium. I'm seeing catalyst. Anybody remembers the compound? It starts with H. Good, hydrogen peroxide, and that's Josephine Vaughn. Good, very good. Hydrogen peroxide. I noticed some people typed hydrogen and then the peroxide came after. Great. All right. Remember that ammonium chloride sublimes. And so if you were to heat, the gas coming off would form dense white fumes. And these are just a few things that we can use to remind us and to identify the original compound. All right, so just a few things about the gases. Hydrogen and ammonia. Hydrogen has a mass, you see there 2, ammonia 17, really light. Notice they're at the top. And then you have some really heavy ones, chlorine at 71, ammonium chloride at 53.5. And all we're doing is adding the masses of the elements. Carbon dioxide at 44, oxygen 32, nitrogen dioxide at 46. So remember that the lightest gases, they have a way to just go off into the atmosphere. And so we have to collect those by turning our container over our tube, and that is called upward delivery, and the others by downward. Just a touch about gases, and of course, please review that, and that is coming on the exam based on what CSEC has put out. All right, so we're gonna identify a few gases. Yes, you know that hydrogen goes out with a pop, and so number 6, really quickly, number 6 is which number? Number 6 goes to which number? All right. Let me go back to
Getting
the
some
chat.
A's. We're getting some
Okay,
A's. Okay.
A, thank you. All right, so you can write the A here. You can write the 6 over there. Or you can draw a really crazy looking line. Like that. All right, great. Let's go back to the top. Nitrogen dioxide. And notice that's the color. Nitrogen dioxide, that's the color. So what color is that, ladies and gentlemen? What color is that?
We're getting some answers. They're giving us, okay, we have brown and we also have the answer as the letter B.
Okay.
Number 1.
Does that sound right? Good. So we're going to take nitrogen dioxide and it's a brown gas and there's a little more information. What does it do? Most of these gases tend to be either neutral or acidic, and so it's going to turn blue, litmus, red. Great. What about chlorine? Chlorine. All right, so we see the color there, and I'm going to switch the color of my marker. And it is, yes, a pale green gas. Now, a lot of students say that it bleaches the litmus paper. It bleaches the litmus paper. So it's gonna turn blue litmus to red and then bleach it. But if you're asked in the exam to write your observation, you cannot say bleaches, it turns blue litmus to red and then to white. So it's gonna bleach it to white. You must write the observation. And then of course, having turned to white, what you're saying is that it has bleached the indicator paper. Great. Oxygen, everybody knows. Oxygen.
Ease.
All right. So relights a glowing splint. And note it is glowing, not growing, and not ogling or anything like that. Glowing. So glowing means you're going to light it, and then you just get rid of the flame and leave that red tip so that it has the ability to relight. Great. Ammonia. Ammonia. And we talked about that a while ago. All right, so F, ammonia is the only basic gas, and it turns moist. Don't leave out that word, moist. A lot of the gases will interface and react with the litmus if there is water present. You have learned that acids can only react if there's water present, and alkalis also. And that's why if you take antacid, Andrews salts, anybody knows Andrews salts? You have to mix it with water. Okay, there's something blocking, which is a chat. Good. So some of you say you know about Andrews. So ammonia turns red litmus blue. Good. All right, water vapor. So we have thrown this one in, water vapor. Some of you might know about it, and you might know something about it and may not know the other thing about it, but there are some tests for water. That one will be in black. Uh-oh, I think I gave that away. All right, what are answers looking like? Yes, C. Well, I guess only C was left, right? So water vapor turns anhydrous copper sulfate. Anhydrous means dry. It also means it has no water of crystallization. And when you add the water, it becomes blue. So anhydrous copper sulfate is actually white, and that's why it's typed in white, and then it will turn to blue. Who can tell me what other substance you can use to test for water vapor? Good, somebody says dry cobalt paper from blue to pink, cobalt paper, cobalt chloride. Good, very nice. All right, give yourselves a high five and a thumbs up. You have done well. So it is time for karaoke. It's karaoke time. Quali A, Quali A. To ID compounds, this is the way. Quali A, cat and ionosate. Use flame test, use gas test, use smell test, use color test. Quali A, the ID compounds, this is the way. Quali A, cat and ionosate. Add dropwise or in excess. Reagents, there's no need to guess. Hydroxide of sodium ammonium is best. Quali A, to ID compounds, this is the way. Quali A, cat and ionosate. Transition cations of colors you see. Yellow, blue, orange, green. Lead 2, copper 2, iron 2, and 3. Make it easy as 1, 2, 3. Quali A. To ID compounds, this is the way. Quali A. That and ionosate. Halide test use silver nitrate. This time see the color of precipitate. Chlorine, iodine, and bromine. White to purple, yellow, and cream. Quali A. To ID compounds, this is the way. Quali A. Cat and ionosate. That really sounds good. Yeah.
That's an ion, of course.
Okay, so that is just to remind you of the different changes, the colors, and some of those pictures were taken right at our school. Some were done by the students, and some, the test tubes just posed so we could take some of those pictures. And just to remind you, the different colors, precipitates, and of course, colorness. All right, so a typical exam will look like this. And they'll ask you to complete the following table. Now you can complete it by inserting observations. Sometimes they ask you for the inference. So the inference is almost like your discussion, telling them what is possibly present, and then to confirm. And notice in the third section, and let me get my pointer, in the third section here, you have Ionic equation required. Normally in qualitative analysis, you are going to write ionic equations as opposed to molecular. Sometimes they'll give you the test blank and ask you to fill it in, having seen some results and or inference. And so it can work either way, and you will see some other examples. So we are to complete the following table by inserting the observations that were made when various tests were carried out on substance H. Okay, so before we do that, we are going to review. Quickly. Does that look familiar, ladies and gentlemen? So please bear in mind, if you are given a planning and design to identify a substance, please do not put it in a 250 ml beaker. Do not add 100 mils of substance and then a couple drops of your test sample or your sodium hydroxide or anything. No, you're going to use a rack of test tubes. You're going to put approximately 10 mils of solution, and then you add your reagents dropwise, then in excess where applicable. So let's do a quick review. Aqueous sodium hydroxide. Now, if your sample is a white salt, usually soluble in water or soluble in aqueous solution, and you add sodium hydroxide dropwise and you observe a white precipitate, quite possibly, and you're going to write possibly, you must put the cation, or if you're doing anions, and for sodium hydroxide and ammonium hydroxide, it's cations. Make sure you have the correct charges when you are writing, and you say possibly because it's not confirmed yet. Notice also that the table is quite small, so do not write very long sentences. We're just writing very short phrases. So do not put calcium as in calcium metal. Do not put lead, L-E-A-D, zinc, Z-I-N-C, or aluminium, because that would be the metal. You must put Ca with the charge at the top. Please remember, and try to remember your charges also. Now, when you add sodium hydroxide solution in excess and you get a white precipitate, it is calcium 2+. The other three, lead, aluminium, and zinc, are soluble in excess. And the teacher once told us back in the day that Lazarus did not remain in the grave as a precipitate, but he rose from the dead, and so he was soluble. So in sodium hydroxide, lead, aluminium, and zinc, Laz, are soluble in excess, having given a white precipitate first. Bear that in mind. What happens in aqueous ammonium hydroxide, also called aqueous ammonia? If the sample is a white salt soluble in water, and you add ammonium hydroxide solution dropwise, you expect a white precipitate to tell you that it's possibly Pb2+, zinc 2+, Al3+. So you're getting closer to some possible answer. When you add ammonium hydroxide in excess and you get a white precipitate, it's only aluminium. So please remember that only aluminium will give you a white precipitate with ammonium hydroxide, whereas zinc and lead will give you soluble in excess. So my question now is, how would you differentiate lead 2+ and zinc 2+ ions? So aluminium gives you a white precipitate, and you are left now with lead and zinc. How would you differentiate these two?
Somebody has suggested lead iodide.
Okay, good. So somebody says lead iodide, and somebody said, and then potassium iodide. So lead has pale precipitate with, so is it lead iodide or potassium iodide? And if you're trying to find lead, then you cannot add lead to your good. So it's potassium iodide. And we expect, as it says here, a yellow precipitate. Now this color is called canary yellow, or some students will say a bright yellow precipitate. And somebody's saying we can use solubility to differentiate. We're now going to use potassium iodide solution. And when you add it to this, a sample of the soluble salt, if you get this really bright yellow precipitate, and notice some has deposited already, this will confirm Pb2+ ion. Okay, very good. So yes, solubility and ionic precipitation. This is ionic precipitation, and we'll talk about that in another few minutes. I'm gonna go back. All right, so transition elements. These we should know. Iron 2 in sodium hydroxide will give you green precipitate dropwise and in excess. Iron 3 will give you an orange-brown precipitate dropwise and in excess. And copper 2+ will give you blue-green precipitate dropwise and in excess. Now the iron 2 in air, if you leave it in the test tube holder in air, it may go orange-brown because iron 2 will be oxidized to iron 3. A quick way to remember iron 2 and iron 3. The blood in your vein, if you look at your vein, it's green. It carries deoxygenated blood. And so the iron is reduced, 2+ is green. And of course, when it's oxidized to the 3+, our blood is red. And I always ask my students, if someone out there were to get a cut, let's put it that way, why does the blood in the vein that is green turn red? Why does it turn red? Anybody knows? And somebody says red-brown, you can say orange-brown or red-brown. Yes, it is a color of rust. It is exposed to oxygen, good.
Right.
And as soon as it is exposed to oxygen, then it becomes oxidized to iron 3. The same thing happens in food and nutrition. If you bought a piece of beef in the supermarket and it is covered with saran wrap and you know that white tray, sometimes it looks sort of greenish. And when you take off the saran, it goes red as soon as it is oxidized or exposed to oxygen. All right, and somebody says yam. So yam, you're telling me that yam contains iron. That's why Usain Bolt ran so fast, because yam has iron. Yam actually has sugars for those who do food and nutrition. And so you have some reactions going on there, just like ripe bananas that go brown, you have a Maillard reaction. Okay, good. So we are relating now colors to different reactions. Aqueous ammonia, and somebody says eating an apple. Yes, I think it soon be time for a snack. Aqueous ammonia or ammonium hydroxide solution. When you add dropwise, iron 2+, you'll get a green precipitate, which again may grow orange-brown in air, or red-brown, or brown, or dark orange. And Fe3+ will give you the orange-brown precipitate, again, the color of rust, and many times you can also smell it, okay? Not that you're gonna walk around smelling in the lab, but sometimes you pick it up, you don't actually waft towards you, but you can detect it. Now, copper, in excess, aqueous ammonia, you're going to get a deep blue solution. So you'll get your blue-green precipitate dropwise, and then in excess, you will see a really nice deep blue solution. And hopefully it will come up. Go back to my pen and see if it will come up. Okay, so that's what it looks like. So it moves from that bluey-green precipitate to a deep blue solution. It actually almost looks like, anybody knows the Vicks bottle? It's a really nice blue, or your blue marker that you use on your whiteboard. Really nice shade of blue. All right. So review, writing the Ionic equations. How do we write the Ionic equations? Let me get another color. How do you write the Ionic equations? If you're using sodium hydroxide or ammonium hydroxide, the only thing you're going to need is your OH minus, and you only write the equation if there is a precipitate. You don't have to write it in each empty block. You're going to write it where you see Ionic equation required. And if your ion, which gave you the precipitate, is, let us say, aluminium, then you're going to write Al. And the charge on aluminium is 3+. And because this is ionic precipitation, everything on the left is aqueous. And the substance formed on the right is going to be a solid. Precipitates are solids. Now you're going to look at the charge on the OH, on the, sorry, Al. The charge on the Al is, anybody telling us? Good, 3+. And so how many OHs will we need? How many OHs? 3, good. Put your arrow. And now we're going to write Al. And of course, persons who have been looking online might see some other complex substances. But at this level, you're going to write your Al. And if you did your crossover technique, anybody knows about crossover technique? Good. So it's going to be Al. Put your brackets. If you don't put your bracket, then you're going to have 3 H's and no O and 1 O. And all of your equations follow along this line. Good. I see Damik Ferron writing formula in, and see I put a for aqueous. So let me erase that. And it's S. Good. And Ruth also put her formula. Very nice. All right, so that's your ionic equation. Don't worry about the sodium and the ammonium and what's going to happen to it. Just keep it simple. Yes, basically, yes, swapping the charges, good. And of course, if you had a 2+, let us say a calcium 2+, let's do a quick calcium. Technique is called crossover or crossing over technique. Yes, thank you, Dr. Taylor. All right, so the charge is 2+. Good. Make sure you know your charges before you go in exam. Makes life easier. All right, and we have our OH. And as we said, it will be on the YouTube channel. They will tell you where to look, I'm sure, really soon. Add your OH minus. How many OH minuses do we need? And remember, in chemistry, you write your equations. Equations are the written language of chemistry. All right. And how many? Yes, so 2 OHs. Good. Okay, what a strange looking 2. Okay. Then your arrow. Remember, no equal sign. And then we swap, and it's Ca. Please remember your OH minus. That's a very poor bracket, but we work with it. Yes, and I see students, and the solid is in. Good. Very nice. Simple, simple, simple. So now we're going to do lead. Let's do a quick lead, and then we'll go into our question. So you told me that lead reacted with the iodide. You don't need the sodium, and you don't need to know lead what, because of course, the precipitate will just form that bright yellow precipitate. What is the compound that is formed, ladies and gentlemen? Which compound is that? The bright yellow. You must remember it from the song. Quali A, Quali A. Okay, somebody says lead iodide. All right, let's go, great. So the charge on lead is, what's the charge on the lead? 2+, good. Remember, everything on the left is aqueous, it's ionic precipitation. So it's aqueous. And now we're adding iodide. What's the charge on the iodide? Good. I'm seeing a lot of 2+s, good. All right, so I'm seeing a minus for the iodide. Great. And if the iodide has a minus like the OH, how many do we need to balance? 2, great. And that came from Anicia first. Again, aqueous. And again, this is just review. And we go over and we end up with PB. Who's writing the formula? Great. So it's PBI2. Somebody wrote OH by mistake. I know it's a mistake. Good. And Forrester wrote the equation and forgot the state symbol over on the right. Good attempt. Remember that lead, the second letter is lowercase. Good. And I'm seeing some PBI2s and I'm seeing some solids. Okay. So we have the hang of this here. Really good. Really nice. Give yourselves a thumbs up. Yeah. Okay. I'm loving this. And as I said, Time is really flying. We haven't even started a question yet. So that's just a basic review, looking at the different tests really quickly and how to decipher what is what in terms of cations mainly. And we looked at some anions here. And now we're going to look again at the past paper question. You want me to leave this up for 2 minutes? Anybody want to take a picture or snip and clip? You may do so. Any questions at this point? You can write in the chat. Any other questions, let me say. So you have the crossing over technique. All right. Then you have ionic precipitation, where you have aqueous ions on the left forming your precipitate or your solid on the right. Also, remember, you have to balance your equation based on your charges, your cation and your anion charges. So remember to look at your charges, remember to know your charges. Now, one quick tip for your exam: if you don't remember something, write something. It is better to write something than to leave it blank. If you leave it blank, there's no mark to get. If you write something that kind of almost sort of might kind of really, you kind of sort of might get a mark. Do not leave anything blank. If you go in the exam and feel panicky, look for something you know. There must be something on the paper you can do. Even if it is just to plot the graph, do that and it will help to relax you. All right, you have this. I don't know if anybody listens to the news about what's happening, but we have some time within which to study and to get this all sorted out. All right, can I go ahead now? Let me know. Okay, I saw sure. Okay, miss, yes, miss, yes. All right, that's 4 out of 100.
200.
200. Okay. And somebody said, yes, ma'am. And one said, yes, me wish. Okay, good. All right, so let's go. All right, so this is our question again. This is the first of a few questions. And questions used to be written slightly differently at some point. I have checked through the years. Most of them are in this tabular form. Some of them used to be like a food web, but I have not seen that in a number of years. So this question normally comes in the data analysis section, which is your first question. But of course, you can actually get a redox question like this. You can actually get an acid-base salts question like this. So when you are looking at the tests and you're looking at if they give you observation or they give you the inference or they ask you for the inference, look extremely carefully at the questions to see if you can identify the topic that is being discussed, the topic. If it's acid, base, and salts, is it redox, or is it straight qualitative analysis? All right, so this is substance H, and we are to complete the table by inserting observations only. Notice they ask for observations. I hope nobody writes over the inference side. You will not get any marks. Do not write over this side. Notice the bullets. There's one here, there's one here. And this gives you an idea along with the number of marks for the question. All right. I actually did not put any marks here. 2, 4, 5, 6, 7. I think it's 7 marks. Look here, there's one bullet, there's one here. So you must write something here. There's another bullet here. There's one that matches here. There's one here, there's one here. There's one here, there's one here. And again, sometimes your equation is for 2 marks and sometimes it's for 1, but they will tell you. All right. 2 marks will get to your state symbols, correct balancing, and correct reactants and products. 1 mark might also do the same thing. Here you have 1 bullet and your Ionic equation required at this bullet. So you're going to write 1 observation. And then here you have 3 inferences, but you're going to write 1, 2. A sample of H was heated and a glowing splinter. That's 2 observations. And so this statement is telling you something. Let's go now. Any questions about that? You're only writing in the observation section, not in the test and not in the inference. So you're going to use the test and the inference to tell you, give you the clue as to what to write on the observation. All right, good. Let me check the chat before I go on. All right, people have started answering already and gone to the second one already. Okay, so let me get my pen. Prefer to type, but I'd have to come out of slideshow. So let's write. All right, sodium hydroxide solution was added dropwise and then excess. So the first thing you're gonna write at the top talks about dropwise, and the second one talks about in excess. Okay, so if it is calcium, aluminum, zinc, and lead, and somebody wrote it already, what should we write here? And you do not write a long sentence. It's gonna be really short. And CXC does not want you to write on the sides. Don't write at the top here. Don't write over the corner here. Don't squeeze up anything. You know, some people love to write. I love to write. I did a driving test once, and at the multiple choice, you know, they asked if it's a one-way, which direction they should go. And I wrote that if it was a highway one-way, you could go on the left or the right side. And the person was reversing up the one-way, and I wrote a whole heap, and of course they failed me. My first multiple choice driving test paper, I failed because I started writing if, and so on and so forth. So don't write all around this paper, because when it is uploaded, they're only going to see what's here. Okay, so somebody said white precipitate. Do we all agree? White precipitate? Yes, okay. So I'm gonna write white. And the shortened form for precipitate is I saw somebody said they like the beat of the quality A. White precipitate. Okay. A question here from Ariane. Wouldn't we say insoluble white precipitate? For the dropwise, the first thing is going to be white precipitate. And no, you will not be marked down for shortening. If you want to spell out precipitate, you can. All right.
Mrs.
Yes.
Williams, can you
Yes.
make the point that once it is insoluble, then it's obviously a precipitate. So writing insoluble precipitate is not necessary.
It's not necessary. I think I'm hoping they think that when they get to the excess, then they would say it remains, if it remains insoluble, if that is the answer. All right. But once it's a precipitate, it is a solid. All right. Good question there. And the question about PPT, if you prefer to write the word precipitate, then write it. I don't think you will be marked down for that. Do you think so, Dr. Taylor?
No, not at all. No. It is an accepted shortening in chemistry, PPT.
Just like aqueous.
Right. Mm-hmm.
Yes. All right. So I wrote it for those who prefer it written, and for those who might take the picture. And then tonight they say, what's PPT again? Parts per turbid, terabyte or so. Right. Okay. Good. Now, aluminum, zinc, Las, ions possibly present. What was our observation that we said earlier? All right, so somebody says dissolves to form colorless solution. And this little space here, we can't say all of that. So somebody has written below. Vaughn has said soluble in excess. Good. Everybody agrees with that? Let us know. And if anybody's not following, let us know. If you need us to go back a slide or two, let us know. All right, soluble in excess, you write out, if you want to write out the word excess, you can. My writing is big. Okay, following, good. Some precipitates can dissolve completely, and that's when you get to in excess here, in excess. All right, good. So I note what you're saying, Anicia, but when you add dropwise to identify the calcium, etc., at the first bullet, it would be a white precipitate. And then here now in excess, I'm agreeing with you that it dissolves in excess. Very good. Aqueous ammonia now was added, or ammonium hydroxide solution. So you have to be comfortable using aqueous ammonia or ammonium hydroxide solution or aqueous ammonium hydroxide. Here it says aluminum, zinc, and lead, las again, possibly present. So what do I write, ladies and gentlemen? All right, white precipitate, good. And then what goes in excess for aluminum or lead? All right, I'm seeing aluminum or lead. I think they should say zinc or lead. I think they should say zinc here because we know aluminum would be insoluble. All right, so we'll get that fixed before we post. Let me put it here. All right, good. Possibly present. Notice it possibly present, possibly. Notice it possibly present. Because you're still not sure. And then down here it says Pb2 plus ions present. That means you're sure. Let's go to the test. A few drops of potassium iodide were added, Ki, good. And what is our observation? And we said it in an earlier slide. What's our observation? Yellow precipitate, bright yellow, canary yellow precipitate. Good. So I'm going to write bright yellow. And I say bright because you students are very bright. And I hope you're getting confidence that indeed you know how to answer these. And you do know something, right? Sometimes people say, I don't know anything. What do you know? I don't know nothing. You know something, okay? So bright yellow precipitates.
Mrs. Williams, I think the aluminum is correct, you see? Since you're dealing with ammonia in excess.
In excess?
Yes,
Okay.
so in excess, the ammonia or the lead would be insoluble in excess.
Insoluble.
Right, in excess.
So here for the second bullet, we should put insoluble.
Yes, insoluble in excess. To match the aluminum and the lead ions present, possibly present.
Okay. So zinc will be soluble.
Zinc would have been soluble, so that's why zinc is eliminated.
Zinc forms zincate complex sort of salt. All right. The zincate, it's called a zincate, and you might have seen that in the different types of salts. So try and check that zinc is soluble in excess. All right, so there's no more bullet here. So it's a bright yellow precipitate. And they require the ionic equation. Anybody remembers the ionic equation that we just wrote?
All right, there are some responses in the chat. They're writing the equation. Sorry, so there's a lead 2 plus 2I, give a PB, but that one is not balanced, so they need to balance it.
We went to a stop. Okay, so PB 2 plus, 2I minus, giving you PBI2. I'm seeing that from Ariane Bernard with the aqueous solid, and Nisia also, good. Carisha, remember on the right, it's solid for ionic precipitation, good. All right, good. So we'll write it here for those who want to take their picture. So it's PB2 plus. Good job, ladies and gentlemen. So it's PB2 plus. Everything on the left is aqueous. And because it is 2 and the iodide has a 1 minus, then we're going to need 2I minus. Aqueous. It's PB2 that you just wrote, ladies and gentlemen. That's correct. I2 solid. So remember, on the right, you're getting this confirmatory yellow precipitate, meaning a solid. Good. All right, sample of H was heated in a dry test tube, where on the final bullet of our test, a glowing splint was inserted in the tube. We have 2 bullets, and so we have to look to see what is on the right. Nitrogen dioxide gas evolved, oxygen gas evolved. And the nitrate NO3 minus ions present tells you what the compound, the anion portion is. So that's why you only have 2 bullets here on the observation, because this is confirming. So nitrogen dioxide gas, a sample of H was heated in a dry test tube. What do you observe? Observe is what you see. And every now and again, what you smell, if it's ammonia or hydrogen sulfide or one of those. What you hear, some people hear different things. All right, so what's in our chat? I'm seeing 14. Okay, brown gas. Anybody says brown, orange, orange, brown, light brown, or just brown? All right, reddish brown. Would it be reddish brown? That sounds good. Some people mix up this brown gas with bromine. Sometimes they think it's bromine. So when you get your question, look through it to see, and I like to advise my students, look through the entire question before you start writing. Somebody says a choking gas. All right, hopefully it's done in a fume hood so you won't smell it. And somebody says relights a glowing splint. They have gone all the way down to the second bullet. All right, so brown gas, okay, and a glowing splint was inserted, and I am told splint relights. Notice we are not writing a long sentence, just enough so that they know what happens. All right, now of course you remember that some substances will produce nitrogen dioxide gas when heated and some won't, right? So if you were to use sodium or potassium nitrate, just a quick question, what would be formed? Would you get nitrogen dioxide and oxygen gas? All right, relights or relit if it's in the past tense. Would you get the full mark for which one? Somebody says splint glows brighter. All right, the splint might glow brighter, not grow, glow brighter if possibly there's not enough gas coming off, and you might have seen that if you were at school doing it. All right. But for these test purposes, you're going to assume that you have enough substance coming off so that it will relight. All right, good. The question is, from Cummings, Tonian, would you get the full mark for that? For that, which one, which part? Could you tell us which? And somebody, Kevin, has written an ionic equation. Notice I did not ask for the ionic. Here, I see you have nitrate giving you oxygen, nitrogen dioxide, and oxygen. Yes, I know we have some students who do go above and beyond, but I'll tell you for CXC that they'll only mark that which they have asked you for. And yes, you'll get full marks for shorthand. Yes, you will. All right. Because here you don't have the space to write a white precipitate is formed. The white precipitate formed is soluble in excess or insoluble in excess or anything like that. So you're going to write really short. You can write excess, EXCESS, and precipitate. You can spell it out, but you don't have to write. For excess, I would put EXCS as opposed to X. All right, maybe I would not put EX as in X. I have XS, which is excess. You'll see that, but you can write EXCESS. So let me write that, doctor.
Yes, ma'am.
And it can fit.
Can you make the distinction between the color? Because I think there are some responses with reddish brown. So could you just make the distinction with the orange brown and reddish brown?
The orange brown, I think, tends to be bromine. But again, you have to be careful because it depends on what is in the question. All right.
I'm thinking the reddish brown would probably be bromine and the orange brown would probably be NO2.
NO2.
Mm-hmm.
The picture that I showed earlier in the song was a really dark reddish brown, and it was nitrogen dioxide.
Okay.
So again, you have to look at the context. If it seems to be a bromide as opposed to, so look at the other tests as well. All right, because some books will tell you bromine is orange brown. And then some will tell you nitrogen dioxide is orangish. So also look at the context. All right. And again, sometimes students write things in their labs and then they transfer it into the experiment. As you saw a while ago, some people said that the glow of the splint would get brighter, which will happen if you don't have a lot of oxygen. All right, we have basically finished this question. And let me go back to the equation that was done by Kevin. Okay, so NO3 minus, and put the 3 before the minus, capital N, capital O, and you're saying you get oxygen, O2 minus, you'd have gotten oxygen gas, O2, NO2 gas, and then I'm assuming your O2 minus would be the oxide formed. So I'll assume that is it. Please give me a moment.
You can go ahead and take a picture or write off the information before Mrs. Williams starts again.
They're selling ripe plantain. Anybody wants ripe plantain? Anybody? Doctor?
Not at this time.
Okay. All right. So
oh, could you take off your chat so they can take a picture?
Yes. Mm-hmm. Oh, so sorry. Everybody okay? All right, so we're gonna try another one. Tell me when they're ready, please.
I think they're ready.
Okay. Oh, I put some questions. So what reagents could you use to confirm the presence of the nitrate ion? So apart from heating the dry solid, if you had an aqueous solution of nitrate, and then you describe what you would expect to observe, and then you would identify substance H. So now we know what substance H is. Sometimes at the end of the question, you'll see a line saying identify substance H. So you're gonna tell us what it is, and we're gonna write the correct formula. All right, so I want you to think about it. What reagents could you use to confirm the presence of nitrate ion? And I'm gonna put aqueous. So instead of heating the dry solid, which would be a nitrate, and of course, if the nitrate is higher up in the intermediate section of the reactivity series, you could also add carbon to help decompose it, which would be a thermal decomposition. If you had nitrate ion in solution, what reagents could you use? All right, somebody says concentrated sulfuric acid. And what would that do? It is hydrogen. Oh, in this context, the question before, let's go back. And this does happen. Let's go back. Complete the following table by inserting the observations that were made when various tests were carried out on substance H. So this is H. See that? See H? So now I'm asking you, what is H? So based on what you did here, what you confirmed, who can tell me what H is? And it's not hydrogen in this case. And this does happen in exam. They give you a letter and then you think it is that element. And then you start writing all about hydrogen. So read your question through very carefully and see what is information. And then you see what is the question. All right, looking right here, what has been confirmed? Anybody remember what has been confirmed? Look right here on the table and tell me what is present. Are we getting any information there, Doctor? Okay, lead. All right, somebody says they're lost. Complete the following table by inserting your observations that were made when various tests were carried out on substance H. So here is H. All of these tests are carried out on a particular substance. Remember that qualitative analysis, normally you're trying to find out either the cation or the anion or both cation and anion. So based on your inference, which is kind of telling you what, based on your observation, what it is, I have circled in red. Possibly present tells you it might be there, but present tells you it is there. So some students have been posting. So what is present? What is the cation and what is the anion?
All right, so we're now getting the combination now, lead nitrate.
Okay, good.
Does substance H means the Pb2 plus? Could you just go through again and show them the linking of the cation and then?
Okay, so let's go again. You have the test and we're testing substance H. Let me give another color. Orange. Substance H. So you're going to add sodium hydroxide to a solution of H, same H. You're gonna add aqueous ammonia to a solution of H. You're going to add potassium iodide to a solution of H. And solution means you got your solid and you added some water to it to make a solution. All right, so they were asking you, what is H made of? Now, because it is a compound, a substance, usually it contains a cation and an anion. Having run all these tests, we said calcium, aluminum, zinc, and lead possibly present, and we have come all the way down to say that lead has been confirmed present by the bright yellow precipitate. And so H contains Pb2 plus ions, lead, and then after we heated a dry sample, a glowing splint was inserted and nitrogen dioxide gas is present and oxygen. So this tells us that the substance we started was a nitrate. So if you're asked to tell them now the ions present, it would be lead 2 plus ions and NO3 minus ions present. What is the name of the compound? When you put lead 2 plus and NO3 minus together, we get lead nitrate. Lead nitrate. Does that help? So let me come right here and write lead nitrates. And now someone is going to write the correct formula in the chat for lead nitrate. Notice you had the charges, so you can either do your crossover technique or somebody say exchange the charges to give them the formula. All right, so PB bracket NO3 2, good. Somebody wrote the ions, PB2 plus NO3 minus. You had put it together to write the formula. Remember, formula now will give you the how to write the compound. So these words are very important. Elements, formula, compound, molecule, formula units. So each thing means something different. There's a raised hand, Geraldo Louis. Luis or Louis? Can you unmute him or you want him to type in the chat?
I am asking him to unmute. Just give me a sec. It's not.
Okay.
Nope. I don't know why my
Not
mouse,
unmuted.
my mouse is not I don't know.
All right, let me just do
See if we
that.
can unmute him, yeah. Ask him to unmute.
And then Chantalie wants me to go over the question. What's his name again?
Geraldo Lewis.
Oh, I see.
Louis or something. Are you getting through?
It says ask to unmute.
Right, just click that for me because I'm clicking it and it's not releasing it. No?
Keeps going up. All right, can you try to unmute yourself, Geraldo?
All right, let me unmute everybody and let him.
All right, Geraldo now has on the video. All right, so turn off the video and turn on the other one. You might be having the same issue.
No? Geraldo? All right, I'm gonna go back to mute everybody, sorry.
Okay. I wonder if Geraldo can't type. Okay, good. Try now, Geraldo.
Well, just a little question, just what you are saying, lead nitrate and lead iodide, and well, I know that lead has two oxidation numbers, so 2 or 4. So you say just lead nitrate and lead iodide. I wonder if in the exam, the CSEC exam, you are writing their names, if you are not mark it down because of you are saying lead nitrate and you don't emphasize there is 2 nitrate when you are naming the compounds.
Oh, I see. So we should say lead 2 nitrates.
Yes, yes.
Okay. That yes is correct. If they ask you to name, you can say lead nitrates. But I understand what you're saying. So let's put in the 2. Very good question.
All right. All right. Thank you very much.
Yes.
You can unmute now. You can. All right. Thank you very much.
Yes. Very good. Very good. Can you mute everyone? Mute myself. Am I unmuted now?
Yes, yes.
All right. For the person who's asking us to go over, is it possible when they see the video, or will you need for me to go over again?
They'll get access to the video, so hopefully.
Okay. We have a few more. Yes, go ahead.
Yeah, they're asking to go over again, but just remind them that you will be doing a few more questions.
Yes, ask them if there's anything in particular at any point that lost them. All right.
So the person who wants to go over could, yes, they're saying the reagent part.
The reagent.
Or they could raise their hand and we'll allow them to ask you the question.
Okay.
The person who doesn't understand, raise your hand and we'll allow you to ask your question.
Is it Rochelle?
Yes, Rochelle. Go ahead, Rochelle.
I tried to unmute, Rochelle.
She's unmuted already. Speak.
Okay.
Rochelle, go ahead. Okay, no response.
Sometimes takes a while.
Okay, Tony and Cummins had a question.
Okay, I see Rochelle is unmuted and Tonian is also. So we take Rochelle first. Rochelle?
Or go on to Tonian.
All right, Tonian.
Hello, everyone.
Greetings.
The question 1 and 2, what reagents could you use to confirm the presence of NO3 and describe what would you expect to observe? I didn't get that part.
Okay, so this may not necessarily come in the CSEC question. I just threw it in as a way to also confirm the presence of nitrate if it is in solution, because all nitrates are actually soluble. And so if nitrate is present in the solution, how would you test that? So reagent means what substances, what solutions would you add, or what substances would you add to confirm the presence of the nitrates? And I don't know if anybody was able to.
There were some responses about adding the copper and the nitric acid.
Okay, copper and nitric acid.
That was a long time ago.
Okay, okay. All right, yes. Did anybody see aluminum and sodium hydroxide as well?
No, I don't remember that. I think that they were thinking of additional reagents outside of the usual
yes
suspects.
Okay, good. So sometimes they might ask you a little something extra. I really hope that that will not happen this year because, you know, the circumstances, and that it will be as straightforward as the one that we just did. I have a few more. Geraldo's hand is still up. Tonian.
Just lower your hand, students, colleagues, if you have asked your question already.
Okay. Very good. All right, so I'm gonna go try another. We're gonna try another. There are quite a few, and the references will tell you where they came from. And of course, you will see some in past papers. You can look if you have the booklet, also online. And again, quite a few of them follow a certain pattern, which is really good. Now this one, notice the observations are filled in. The inference, ooh, who did that? I did. The inferences, 1, 2 here, 1 here. So look for the bullets and it gives you an idea of how much you're supposed to write. So now,
somebody
yes.
wants you to turn back very quickly. I guess they just want to get a glance of the last slide.
Okay. And the person said lead 2 nitrate, I started thinking about lead 4 nitrate, which is CAPE. But yes, you can put in the number, lead 2 nitrate. Very good. And then your correct formula. Can we go?
Yes, go ahead.
All right. Okay, so look at this. Let us read the question together. Complete the following table by inserting observations. Inference made. And then I'm gone again. What do they call that? Cut and paste. Okay, so it's inferences. So this one now you're to write, you're to insert the inference. So you have the observation and you are to write in the inference. And the substance we're looking at is, who can tell me the substance? All right, so I'm assuming they said I. So nobody should tell me iodine unless it's iodine. Okay. Here it's I. So the substance we're looking at now is I, and we don't know what I is. Sometimes I use letters like Q and other letters that may not be the symbol of an actual element just by itself. Okay, so sample I was heated in a dry test tube. Pieces of moist, remember that, red and blue litmus were held at the mouth. 1 bullet, the red litmus paper turned blue. The blue litmus remained blue. Okay, so what turns moist red litmus blue? And blue we know is alkaline. And I'm seeing 27, wow. All right, ammonia substance is basic, it's a base. Okay, so the first thing you're gonna write, are you gonna write it's a base? Is that the first thing we're gonna write? We have 2 bullets. Let me see if I can move this down. All right, the chat not moving. All right, so do we write it's a base?
They have ammonia gas first, and somebody says write ammonia first and then base. NH4 plus ion present, then base.
All right, would you say, okay, sample was heated, pieces of moist. The red litmus turned blue. Would you immediately go to ammonia? Because if you confirm ammonia, then would you say base? Or would you say because it turned red litmus blue, it's a base?
Okay, so inference ammonia was possibly present.
All right, so,
plus ions present.
and then this confirms ammonia. That's what they're saying? Ammonia possibly present, and then it's confirmed?
I think they're putting the ammonia possibly first and then something about base.
Okay.
But
Go ahead.
it would be base. Sorry, somebody's saying, it would be base, then ammonium ion present.
Because
So
now you're confirming ammonia.
Yes.
All right, so should we say base first?
Base or basic gas.
And the strangest thing in the observation, it don't even tell you that a gas came off.
Well, it says pieces of moist red litmus paper were held at the mouth. So generally, when it is testing a gas.
Please note also that ammonia is colorless and you will not necessarily see any bubbles or anything, as we said before about when a gas is coming off.
Somebody's asking why. Oh, well, I guess somebody's answering them.
Why about the basic?
Why about the base?
Okay, base means, basic meaning, it turns the litmus blue, alkaline, right? And because it's moist, then you could say alkaline. So it's basic gas, and of course it turns it blue, which means it's alkaline. Suelan Jones, her hand is raised.
Excuse me, you hear me?
Yes, I'm hearing you.
I wanted to, when I was asked, I wanted to know if it matters where you would put like the basic gas or the ammonia, because in my head it was the ammonia first and then the basic gas.
Yes, that's what we were discussing, and we're asking you all, what are your thoughts? Would you put basic first or ammonia first?
So does it matter which one you put first?
I don't think so.
Maybe in this example, it probably wouldn't, but because the first observation was that the red litmus paper changed to blue, that the first observation or the first inference would have to be that it's a basic or alkaline gas.
And someone is asking how we jump from basic to ammonia. Ammonia is the only basic gas that we know about right now. All right, ammonia at this level is the only basic gas. So once the red litmus, moist red litmus turns blue, you know, bam, it's a base, bam, it's ammonia. Or as a student asks, bam, you know, it's ammonia and it's a base. I do not think they would grade you down if you put ammonia first or basic first. And someone is asking what else could you say? Because the paper is now moist, that will also allow it to be alkaline. All right. Yes, ammonia is the only basic gas, only the blue. Well, the red turned blue and the blue remained blue. And some people do both to test, all right? Some only use moist red. So again, look at what is given. All right, sodium hydroxide added dropwise to a solution of I, which is a substance.
Just a sec.
Yes.
Could they have placed the ammonium ion as the second inference?
Ammonium ion?
The NH4 plus ion, yeah. Since the observation would be confirming the ammonia.
Yes, quite possibly they would have said ammonia, they could say ammonia gas and then NH4 plus ion present.
Right, right.
And please bear in mind, everyone, ammonia is NH3, the gas. I know sometimes people get them mixed up. So yes, you could have said NH4 plus, and remember to put the charge. Don't just put NH4 plus. And then you can say present. And of course, you will try and write it in the same section. Don't do like this one here. So you could have ammonia gas and then NH4 plus present as your two bullets, basic gas or ammonia gas, or ammonia gas or basic gas, or ammonia gas NH4 plus present. All right, very good. Are we okay? Can we go ahead?
Yes, go ahead.
All right, sodium hydroxide solution was added dropwise to a solution and then in excess. So we're assuming that the first bullet is dropwise and the second one is excess, and it says here in excess. And so a green precipitate. So I have to get my green pen. So a green precipitate, which one we said gave green precipitate? And it is insoluble in excess. Which one is green? Anybody remembers? Are they saying it?
Yes, they're putting Fe2, Fe2.
Okay, and I'm seeing some Latin and all of that.
Yes.
Okay. All right, so here we put Fe2 plus. Here's my pen. Okay, so it's Fe2 plus, and it's in green, so it separates what was up the top there. And the precipitate remains insoluble in excess. And now in the space, they ask for ionic equation required. So what do we look at our reagents? So we're saying it is iron 2 plus. So we're going to write that first. And what did we put into our test tube? Look on the test. What did we use?
Okay, so we're seeing some, well, an OH minus.
Good. So don't worry about the sodium. Sometimes we forget and then we start writing Na and then we don't know what to do with it. And the charge on the iron is 2 plus. So how many OH do we need?
Okay, 2. Getting some answers, 2.
Okay, 2. All right. I was trying to put the chat at a section where it wouldn't block. Okay. Everything on the left is aqueous. And remember, it says a precipitate forms and the precipitate remains insoluble. So when we go over, our precipitate should still be, our precipitate will be a solid. And so when you do your crossover technique, and notice you're doing equations. I won't even bother to ask you how many moles is formed. 1 mole of Fe2 plus 2 moles of OH minus give you Fe. A hand is up, Tony and Cummings.
Go ahead, Sonia.
Miss, the formula, Miss. Where did the sodium went, Miss?
Okay. In the ionic precipitation, based on what you did, acid, base, and salts, you're going to have one compound that is insoluble and the other compound will be soluble. All sodium salts are soluble, PSA, potassium, sodium, ammonium. All sodium salts are soluble, and so the sodium is in solution. We are only writing the ionic equation to show the formation of the green precipitate. Does that help?
You could just remind them about the spectator ions.
Okay.
Oh, she's saying yes. She's saying yes.
Okay. So some ions don't really participate. They watch the game. Nowadays, you have to watch online. You can't go to champs unless you're running. Well, you have to stay home and watch. And you're at home now, I hope, watching me, and I'm here watching you. Okay, so we are not participating. All right, so the insoluble, we only want to know how to form the precipitates. We only want to know how to form the precipitates. So the sodium remains in solution. It does not participate. It is a spectator. It's only watching. Okay, good. I hope everybody else is okay with that. Now we go to a new test. A few drops of barium chloride. I need a new color. I need a new color. A few drops of barium chloride. Solution, aqueous again. This was added to solution of I, followed by some dilute hydrochloric acid. A white precipitate is formed with barium chloride. What forms a white precipitate with barium chloride? And is it only one thing?
Okay, so there's an answer, possible sulfate or carbonate. That's the only answer I've seen so far. Okay, sulfate.
What's the formula for sulfate, ladies and gentlemen?
And there's some other suggestions. Carbonate, sulfite, sulfate, SO4.
Okay.
They're leaving off the 2 minus.
SO4, remember the ions, 2 minus. And sulfite, what's the formula for sulfite? Ite, and not ide, sulfite, which is another topic on naming compounds, which we won't be doing today. Oh, shucks, I wrote it already. All right, somebody give me the carbonate ion.
So we saw some of the sulfite, SO3. Carbonate,
Okay.
CO2, I think they're writing that wrong.
Okay, so I'm putting CO, waiting.
CO3 minus, no. CO2 minus 4, no.
All right, Swellan.
Okay, yes, just give me a sec.
Okay. Remember to write possibly present. Remember to write possibly present because you're not sure yet.
Go ahead, Swellan.
You go over this because I'm not understanding.
Where did we leave you?
I read the answer really. I'm not sure how we're getting the sulfate and the.
Oh, okay. All right. So just at the third row, barium chloride. That's where we're at. Yes. All right. So barium chloride tests for sulfate, sulfite, and carbonates. SO4 2 minus, SO3 2 minus, and carbonate. So there are certain tests for anions. So in our song, we heard about silver nitrate testing for the halides, chloride, bromide, and iodide, giving you specific pale colors. Now, barium is used to test for sulfate, sulfite, and carbonate. Is there anybody there who learned that it only tests for sulfate? Maybe some of you only heard about the sulfate. I see 2 raised hands. 2 raised hands.
Good afternoon, Miss.
Yes, there.
Miss, just to backtrack a little bit, when you were answering a student question,
Yes.
you said something about barium chloride that it tests for a bunch of stuff.
Yes.
Is there a way how we can study all of that? Just in case you come on exam to say, all right, this in particular test for that, so then it would have been one of the possible options.
Yes. I think that's why I tried to write a song. And of course, if we had time, I would have asked you to add a verse. But I knew the time wouldn't be there to add the verse. So what you can do is post it. When you go on YouTube, you can post a verse about add barium chloride or nitrate. Then you look at the precipitate sort of thing. And then hopefully that will help you. Don't jig and dance in the exam, but I find songs help me. DJs and poems help me to remember. All right. So if you were to write down the test and what it is for, silver nitrate is for chlorides, bromides, iodides, barium chloride or barium nitrate, because they are the two soluble bariums. I'm going to put nitrate. Test for these three things: sulfate, sulfite, carbonates. And then when you add hydrochloric acid to give you a precipitate, who can tell me what this eliminates? And remember, when you add an acid, if it's a carbonate, what happens with an acid and a carbonate? Let me use a different color and take it out of the table. Acid and carbonates. What happens with an acid and carbonate? And we did it on the acid, base, and salts a while ago. Somebody's saying something, yes. Please tell me what
Yes, so they're saying carbon dioxide and water, acid and carbonate form CO2, form salt.
Good.
Yes, salt,
Yes.
carbon dioxide and water, right.
So if you were to add acid to the solution, the carbonate, you should see fizzing. So that would, this doesn't say anything about fizzing. If it fizzed, then you would say it's a carbonate. All right.
So the precipitate dissolves, forming CO2.
Where is that?
Further up, further up.
Oh, somebody asked, is it precipitate
No,
dissolved?
somebody gave that as the answer.
Okay, but
it dissolves, releasing carbon dioxide. I guess they're saying what happens when you add acid to the, if it's a carbonate.
Okay, okay.
Right.
All right. So if it's a carbonate, you hope to see fizzing or effervescence or bubbling. If you're seeing here, the precipitate remained in the acid, what does this confirm? And you can look it up, whether in your text, online, or wherever. Not in exam, you look it up now. And
okay, so one person said sulfate ions will be present, SO42 minus, it's SO42 minus.
Okay. I saw somebody write SO2, 2 minus, when I was peeping a while ago.
Okay.
So you can write these things, you have time, and put them above your head. When you wake in the morning, you thank God for a lovely day, and then you thank God for chemistry, and then you look up and you see SO4 2 minus, SO3 2 minus, CO3 2 minus, ammonia, NH4 plus, iron 2 plus, Fe 2 plus, etc. And you'll sort of remember it that way. Okay, so that will help. So can we say SO4 2 minus present? Can we say that, ladies and gentlemen? Notice the pause. Okay, I want somebody to look and tell me what substances are present. What substances did we say are present? And there's one that doesn't say present, so I'm going to write present. What substances are present?
Okay, so there's a question.
Yes.
So when writing inferences, you should list the possibility before confirmation.
Yes, yes. When you go to the hospital and you are coughing, they will say possibly a cold. Not nowadays, but possibly a cold. You know what they say now? Yes. Then they run the tests. So they swab all the way down to the back of your nose and so on. And then they confirm whether you have or you don't have that thing there. Okay, but they're not just to come and say that you have it. And so when you go to court, they say you are not guilty. You are innocent until proven guilty. Now, Roshan, Karian say that SO4 2 minus, NH4 plus, and Fe2 plus are present. I wonder if that Roshan is my Roshan. Is that my Russian?
They said yes.
Good. I have good company here. All right, so let's get another color. I'm into colors. So NH4 present. And you see why it is good to say this is possible, this is possible, this is present. So that you can look back and see that it's that, this, and sulfate. And I'm gonna ask if anybody ever heard of this compound before.
They're asking for the Ionic equation. I think, would that be for the barium and the sulfate, right?
Yes, so let's get another color. Okay. All right, so Ionic equation, anybody wrote it in the chat yet? The Ionic equation. I will not pick on Russian. Okay, good. So I see Ba2 plus SO4 caret 2 minus. Okay, somebody has brought in the math to the chemistry and a nice arrow. And this is Yannick Henry, BaSO4 solid. So aqueous on the left, solid on the right. Notice now, ladies and gentlemen, we did not put barium, the chloride from the barium. Notice we did not put the acid, the dilute acid either. Is there anybody there who thought we should have put acid, the Cl minus or anything? The screen is really blurry. Okay, let me take this off. And does that help?
I don't think it's your screen. It's possibly their internet connection.
Okay. Remember that they have posted where on YouTube you can see all of it all over again. They call that, what they call that? When you rerun the show, right? Okay, and then you can take your pictures, you can stop it, you can rewind, not rewind, you can replay. Rewind is old time song word, right? All right, so we are going to put, as you have, barium, and the charge on the barium is 2 plus, and the formula, the symbol is Ba. Again, it can be barium chloride or barium nitrate. Everything on the left is aqueous, as we have seen in the chat. It has been written, very good. I commend all of you. You have been participating very well, and there are 2 hands raised. You have been behaving very well. I am so impressed. Don't do like me and write off the little table. Try and write as small as possible. Remember, sulfate is SO4. Remember, it is 2 minus. Since you have 2 minus for the sulfate and 2 plus for the barium, when you exchange, cross over, what will our final thing be? Before we take those questions there or comments. So it's Ba. I hope nobody wrote Ba2 SO4 2. The SO4 would have to be in bracket and then you cancel it and they give you BaSO4 solid. All right. Well done. Can we get those questions or comments, please?
Oh dear, she unmuted back herself.
Okay, she will remember oxygen capital O, barium capital B, second letter lowercase, sulfate capital S, capital O, nitrate capital N, capital O. Yes, great, good, Jada. All right, was she able to unmute her, muted? All right, 2 hands raised.
Nope. All right, see if we can unmute.
I'm looking for the hands. Oh, okay. Thompson and Geraldo. Let's go. Geraldo, your camera. Okay, you. All right. Okay, try now.
Yes.
Yes. Go ahead.
All right. Where in YouTube you are going to or we are going to have the possibility to watch this beautiful session today?
It's posted in the chat. It's on MOE Jamaica YouTube channel. It's happening right now there, so you can just go and check it.
Oh.
But I
Oh, it is-
posted the link in the chat, so you could check by the
Oh,
chat.
it is in the chat?
Mhm.
Yes.
Oh, okay. Yeah, because remember that people are posting message, and it can go up, and we are not
Okay.
able to see
Can you
them.
repost, Doctor?
Yes,
Yes,
was just
that's what I'm
reposted.
saying, yes.
Was just posted over
All
there.
right, thank you.
Mhm.
Thank you
Okay.
very much.
Thank you too for reminding us. And sometimes people fall off and come back on, they cannot see what was in the chat.
Okay,
Any
if
other?
Yeah.
if you're not getting through, just type in MOE Jamaica. That's the YouTube channel.
Excuse me, Miss.
And you can see it live. Yes, go ahead, Thompson.
Miss, I was just asking if when we meet again, if we do meet again, if we're going to go through some past paper questions, or we would have to do that on our home.
Mrs. Williams is actually doing past paper questions, but she will answer it.
Oh, I'm sorry. I thought that she was the one who, set the questions. I didn't realize.
They are past paper questions.
I will tell you that even if I set the question, it would be along the CSEC guideline. All right. Now, unfortunately, it is 5.00. Shade's hand is raised. I'm gonna flip to another question. And if you look in the chat, it's actually in the references, it will actually tell you the year. One of them is, I think, 2006. So all these are basically past paper questions. I'll come back to this, but if you look, Caribbean exam 2005, it was written May, June 2007, paper 2, and the page 4, section A, question 1B, okay? And of course, some from the Tyndale revision, the workbook and the revision course. These are all similar questions. Go ahead, Shade.
Miss, for the barium one, couldn't we add barium? Are you hearing me clearly?
Yes, I'm hearing you clearly.
Couldn't we add barium hydroxide plus sulfuric acid, which equal to barium BaSO4 plus water, and it would be correct, right?
Barium hydroxide. Remember that all hydroxides are insoluble except PSA, potassium, sodium, and ammonia. And so it would not be a solution. So only barium chloride or barium nitrate can be added.
Okay.
All right.
Okay.
I hope that helps. Okay. I remember it's ionic precipitation. Everything on the left should be aqueous, going to give you a solid. All right. So when you do, how are we gonna do this? Okay. So I'm gonna leave this up for a few minutes so that it's captured live. And then you can snip it, clip it, take a pic of it, and try to do it. And then you can post your responses. Again, if you have any questions, and you'll see some similarities. This one, I'm leaving it up for a few minutes so you can look at it. This one is sample K.
If you have
Sample.
the time, you can continue. We're not gonna cut you off.
Even though it's 5 p.m.?
Even though it's 5, we'll continue. What do you say, students? Do you want me to continue? Type in the chat. Okay, there are a number of yeses.
Learning never stops. Somebody wrote something I'm trying to catch, but where is it? Somebody actually wrote. Got it. Oh, somebody said they speak Spanish. Okay, somebody said let our brain explode with knowledge. And it bursts out, yeah. All right, so I'm actually putting them up so that you will see them, but I want to highlight something. All right, so look at this one. And this sample is K, solid K. And of course, remember now, sometimes it's a solution, sometimes it's a solid. A sample of K, which is a solid, was heated strongly in a dry test tube under glowing splint. So once you see the glowing, we begin to think oxygen, yes? Is that so? And brown fumes. Notice this doesn't say reddish brown, orange brown, but brown fumes and the splintery light. So you know that's oxygen. And therefore, we are not expecting anybody here to talk about possibly bromine gas. You see that, ladies and gentlemen? Because of the test done, it was heated strongly and a glowing splint was put in, giving you the brown fumes of NO2 and the glowing splintery lit of oxygen. So this tells you that it's possibly a nitrate. Okay? Again, sodium hydroxide, ammonium added, and then you can tell them possibly what it is. And because ammonium was added, white precipitate soluble in excess, that is, I think, confirming zinc. And then now, remember the silver nitrate, and we talk about white precipitate to purple. It says silver nitrate. Now the purple would be in bright sunlight. It doesn't say that here. It says followed by aqueous ammonia. What happens with aqueous ammonia? Once you see silver nitrate and it says chloride ions, that tells you, and it's one bullet. So that would then say, you'd have to say the color precipitate. And what happens when it's followed by aqueous ammonia? Who can tell me?
Okay, so somebody's saying it is soluble, soluble, insoluble, precipitate dissolves, soluble question sign.
So you must say white. I'm just touching some of this. You must say white precipitate. And then you say soluble in, that's white precipitate, soluble in aqueous ammonia, yes? Notice you don't say soluble in excess. Read the question. Read the question, okay? And if you were asked for this is aqueous ammonia. If you were asked for the Ionic equation, which is there, don't put in the ammonia. All nitrates are soluble. What are you going to put in? Since chloride is in the inference, you know that you must have chloride ions. What will you put in from the test to write your Ionic equation to give you ionic precipitation? While I write this word precipitate. Type in the chat quickly.
Not seen any response as yet.
Okay.
So there's silver chloride.
Okay, good.
Silver chloride, question sign.
Yes, so all chlorides are soluble except lead and silver. So now, since you added silver nitrate and the nitrate part is soluble spectator, then it's gonna be silver with a 1+ charge. Aqueous on the left. And solid on the right. Chloride ions have what charge, ladies and gentlemen? Group 7.
Getting the minus.
Good.
Minus negative.
And of course, when you do your crossover or you exchange, you get Ag, and both of them are 1 charge. So it's AgCl solid. Very nice. And here, white precipitate soluble in excess. In case you're wondering, you would write your equation for your precipitate. So don't worry about the ammonia and it's going into become a solution again. So write your equation for your precipitate. And notice the pattern of the equations. Always remember, Chemistry is about patterns, relationships, and trends. All right, great. Now I wanted to highlight something before I finish. And this came in the 2007 paper. Can I move from this page? Are we good? Any questions, any comments?
Are you going to fill up the other sections, the inference?
I did not plan to. If you want us to, we can. I really want to show them this question because it came one year.
No problem, no problem, no problem.
Okay. I am going to send, you can type it in the chat part of the YouTube. I also have an email. So if you have any questions and so on, or you saw something on a paper and you want to ask, that's fine. You can do that. That's no problem. All right. But I wanted to show you this. Let's see if it's this. Yes. Is it this one? Yes, it's that one. How do I go back? Okay. Is it this one? The point I wanted to make is if you have a yellow precipitate, one of the exams one year actually added lead. They added lead, right? They actually added lead nitrate. And then when they asked with the yellow precipitate, because students study a certain way, then they wrote in the inference that lead was present. You have to look at what you're adding. Look at what you're adding, okay? Please look at what you're adding. So if you're adding, let us say you're adding lead nitrate and you get a yellow precipitate, you cannot now say that lead is confirmed, okay? Or if you're adding, in this case, potassium iodide to give you yellow precipitate, you cannot say iodide is present because you just added it. I want you to bear that in mind. So you must look at what you have added and then look at your observation, if it's there, and write your inference, or if the inference is there, then you write the observation, okay? Now you can see from these questions that there's a certain pattern. You can see that sodium hydroxide comes, ammonium hydroxide comes, potassium iodide comes, the barium comes, the silver nitrate. So learn those to help confirm. You have some little confirmatory, adding excess, adding acid, adding ammonia, a few confirmatory. Note those well, bear them in mind, okay? This is an ed puzzle, so you can, and if I can get it in the chat. This actually has unknowns, I think, cations for you to identify. And it's a video that you watch with questions, which can also help. Quite interesting. And it's like solving mystery powders lab. So it's from the internet, and then we put it in an ed puzzle. Why do I have the eraser? Okay. So we'll see if we get this into the chat as well, or you can take it from the YouTube. And you can also watch, this is my class, Roshan is here, and we did qualitative analysis when we were allowed to come back to school. And one of my students, Alia, compiled the video of all the tests that we did on this substance. So it's really interesting. It's on YouTube as well, so you can look at that. A nice refresher, and it's an actual practical that you can look at. You can like Chemistry Simplified series on Facebook, and you can email me at chemistrysimplifiedseries@yahoo.com. Again, you can also write your questions under the YouTube video, and I will try to respond, and Dr. Francine will also be available to respond. I hope that this session was beneficial. A few references. And
Somebody's asking you which school you teach at, and they want the link. Is there any way you could put the link to the Ed Puzzle and the YouTube in the chat?
Okay.
Right.
All right, let me come out of everything then. Any other questions? Any other comments?
They're asking about moles. Tell them moles will be done tomorrow.
Moles is coming. Remember, you're going to have review tomorrow and Thursday. Let me get those.
And Friday, Thursday and Friday.
Oh, see? Week is finished already. Okay. So Ed Puzzle. Somebody says, and physics.
They're asking if there's any biophysics.
Okay. All right. So this is for the Ed Puzzle. Can you see it? Ed Puzzle?
Okay, I'm seeing it, yes.
All right, this is for the video. And it is, you're welcome, Shantana. And my email is chemistry simplified series@yahoo.com. There are also some videos on my Facebook, which is Chemistry Simplified Series, 3 separate words. I have been trying to cook chemistry at home, so there are some videos there. Also, some other questions and things like that, so you can look. I hope you enjoyed this session. Somebody said, Miss Elaine. I hope you enjoyed this session as much as I did. Dr. Taylor Campbell, I enjoyed this session.
Oh, yes, we did. Students and colleagues, can you clap your hands, use the reaction button, and just tell Miss how much you appreciate the session? All right. So remember to check out all of those links that were sent to you. Okay. There will be another session, yes, Thursday and Friday. All right, dealing with different topics. Yes. Go ahead. Tell Miss how much you appreciate her help this evening.
Thanks.
Very good.
You know I have to close out with this song, right?
Yes,
you know I have to close. I have to close out with this song. Yeah.
Special request.
Where is the PowerPoint? Oh, there it is.
Yes, find that song.
Thank you all. Thank you so much. All right, so it's karaoke for those who missed it. Karaoke time. Quali A. To ID compounds, this is the way. Quali A. Cat and ion assay. Use flame test. Use gas test. Use smell test. Use color test. Quali A. ID compounds, this is the way. Quali A. Cat and ion assay. Add dropwise or in excess. With reagent, there's no need to guess. Hydroxide of sodium, ammonium is best. Quali A. ID compounds, this is the way. Quali A. Cat and ion assay. Transition cations of colors you see. Yellow, blue, orange, and green. Lead 2, copper 2, iron 2 and 3. Make it easy as 1, 2, 3. quali A, quali A. For ID compounds, this is the way. Quali A, cat and ionosate. A light test used silver nitrate. This time C, color of precipitate. Chlorine, iodine, and bromine. White, purple, yellow, and green. Quali A, the ID compound, this is the way. Quali A, cat and ionosate. Quali A, the ID compound, this is the way. Quali A, cat and ionosate. Yeah. Sounds good.
You should have mentioned that they should be bouncing, you know?
They should mention what?
They should be bouncing, and, you know, hands up in the air.
All right, so anybody who can write a verse, you can post it in the YouTube so that we can see. All right, post it in the YouTube. Thank you all so much. I wish you all the best in your exams, and the Lord be with all of you. All right.
Okay, thank you, Miss. It's a different link each day. But you can always go to the YouTube channel and look for MOE Jamaica Live, and you should see the live streaming of the sessions. All right, thank you very much. If you have missed out any part, you can always check MOE Live, MOE Jamaica Live, all right? The link is being posted in the chat. Thank you again to Master Teacher, Mrs. Elaine Williams. I'm sure you wish you had her as your class teacher, right? Anyway, so join us again tomorrow. Thanks for participating.
All right, so Ed Puzzle again, and YouTube, and I just saw Michaela Clark. Woo! Is that my Mickey? She is my class teacher. Okay, wonderful. Thank you all the best. And as you heard, make sure that you log on. They say log on nowadays. Yes, make sure you're on tomorrow and on Friday. Again, you can watch them over and over. You can clip, snip, and try the questions. Try the questions that are there. And as I said, write a verse. Write a verse and post it. We're learning together. Thank you so much. Have a great, great, great evening. And keep safe. Keep safe.